Frozen plains, icy mountains with their snow-capped tops glistening in the sun, valleys, craters, eternal freezing winter.
Wow. Hello there, Pluto. At first sight, it looks like a paradise for adventurers who love skiing, snowboarding, and all the other fun things you can do in snowy winter wonderlands. But the snow there is not like what you can find on the mountains of Earth. On Pluto, the mountain peaks are covered with frozen methane, while down here they're made of frozen water crystals. Because of its specific chemical composition, the snow on Pluto is red. The mountains themselves are very different too. They reach heights of up to almost 10,000 feet. But they're not rocky like ours, looking more like huge blocks of ice. Such a landscape cannot be found anywhere else in our solar system. But you'll need to pack some layers if you want to come visit. The average temperature there ranges from minus 375 to minus 400 degrees. When taking a look at it from a distance, you can see it has some kind of big, heart-shaped thing on its surface, called the Tombaugh Regio. That's actually a vast plain the size of Oklahoma, or Texas, that's covered in nitrogen ice. Scientists discovered this heart actually makes the winds of the planet blow. Craters are also big here, sometimes more than 160 miles in diameter, and some of them show signs of filling and erosion. Erosion is when land is worn away by natural forces such as wind, water, and ice. It's the same process that formed many interesting things that you can see on the surface of the Earth, like valleys, coastlines, peaks, or mountains. The fact that some craters are there because of erosion tells us that tectonic forces must be slowly changing the surface of Pluto. 1/3 of its surface is water, but not the kind that we like to drink, more like a really hard frozen ice. Water is vital for the evolution of life, but not water that's this cold, so it's unlikely that any life has formed here. At least for now. But how do we know all these things about Pluto? Well, here's the basics. Astronomers discovered Pluto in 1930, and just like with plenty other moons and planets, they named it after a figure from Roman mythology, the ruler of the underworld. Pluto was considered the 9th planet of our planetary system until 2006, after which it was recategorized as a dwarf planet. Despite its recent demotion, it is still the largest and the oldest known object in this region of the Kuiper Belt, an outer shell full of other dwarf planets and icy bodies. New Horizons. That was the name of the very first space probe that astronauts sent to have a look at Pluto in 2006. It reached a distance of up to 7,800 miles. While there, it took some important photographs and collected lots of important information, and discovered some of the mysterious cosmic oddities found on the surface of Pluto. One interesting thing about this former planet is that it sometimes has an atmosphere and sometimes not. It has an oval-shaped orbit, which means, unlike most other planets, it doesn't travel around the sun in almost perfect circles. As a matter of fact, the sun is nowhere near the center of its orbit. When its orbit takes Pluto closer to the sun, the extra heat warms up a kind of thin atmosphere made primarily from nitrogen, an element our Earth also has in its atmosphere. Right after it's created, it gradually escapes Pluto's weak gravity. When the dwarf planet moves away from the sun, the atmosphere freezes and goes back to its solid state, falling back down to the surface of Pluto as nitrogen snowflakes. Pluto's interior is supposedly warmer than its surface. Some believe there's even an ocean deep underground. Despite being the largest known body in the Kuiper Belt, Pluto is still pretty small. It is smaller than the Earth's moon, around half the width of the United States. It has 5 spinning moons of its own, the biggest one half the size of Pluto itself. Our days last 24 hours, while one day on Pluto lasts 153. Earth needs 365 days to orbit the sun, while a year on Pluto lasts 248 Earth years. So, no birthdays there at all. It sits 3.6 billion miles from the sun, which is 40 times the distance of the Earth stands. If you were standing there, on Pluto, watching the night sky, you'd see the sun as just one small distant star, indistinguishable from the rest. Since Pluto has been demoted, Neptune is now the most distant planet of our solar system. It's also pretty fascinating. It's actually a huge ball of ice and gas. Yes, it's the densest gas giant in our solar system, but you still couldn't stand or walk on its surface. You would simply sink in. But if you could stand, you'd notice that the gravity force is similar to what we have on Earth. Despite its impressive size, though, Neptune is not visible to the naked eye from here. It's the windiest and coldest planet. And 1 year there lasts 165 Earth years. Still no birthdays. It takes more than 4 hours for the light coming from the sun to reach Neptune's surface. Our next gas giant is Uranus. 1 year on Uranus lasts 84 Earth years, so you can maybe get one birthday in there, but you better make it count. Just like Neptune, Uranus can't be seen without the help of advanced technology. The rest of the 6 planets can. But you can still see all 8 of them with binoculars or a smaller telescope. Now, pause the video, see if you can make your astronomy teacher proud, and try to remember which planet comes next in order from furthest to closest to the sun. You got it? That's right, it's Saturn. A+. Saturn is the 2nd biggest planet of our solar system, right behind Jupiter. And another gas giant where you'd sink in if you tried to walk on it. It's so gassy, you could put it in a lake and it would float. They call it the jewel of the solar system because it has a big ring system that kind of looks like a crown. Its rings are made up of dust, pieces of ice, and rock. Some of those pieces are as tiny as a grain of sand, while others are bigger than tall buildings. Next on the list, and completing our gas giant quartet, is Jupiter. Scientists call it a failed star since it's mostly made up of helium and hydrogen, just like the main star in our solar system, the Sun. But Jupiter doesn't have a mass big enough to start the chemical processes that turn it into a star. However, it is still the 5th brightest object in the solar system, right behind Mars. You probably have seen it when stargazing sometime, you just had no idea what it was. Okay, picture all the other planets combined and double their mass. That's a lot of mass, but Jupiter still has more mass than that. It's also the fastest spinning planet, so it takes only 10 hours to complete a full rotation on its axis. Our day lasts 24 hours. Imagine how it would look like to squeeze sleep, work, family, friends, hobbies, movies, all that in just 10 hours. I guess I'd have to sleep once every other day if I lived there. Now, picture this. Magnificent tall mountains, giant dust storms, volcanoes, deep valleys, craters. Mars. That red jewel scientists keep talking about being a potential new home for us. There were even some small meteorite pieces found on Earth that scientists realized were ejected from Mars. That's how close we are. If you love sunsets, you would definitely enjoy the ones here because they're incredibly blue, while the daytime sky is pinkish red. But when on Mars, you'd only see the sun at half its size compared to what we see on Earth. And of course, there's Earth itself. Seas, mountains, valleys, waterfalls, and of course, life. For 4.5 billion years, Earth has been home to so many different kinds of organisms that have lived, died, and lived again. And even though we know so much about our homeland, there's always something new to discover each and every day. The next planet, Venus, is the champion of superlatives. The hottest surface, the closest planet to the Earth, the biggest number of volcanoes, 1,600. If you compare it to other planets to our solar system, the brightest planet, with reflective clouds that make it so shiny you can see it from the surface of Earth. Oh yeah, and the slowest spinning body as well. It takes 243 Earth days for Venus to make just one single turn. You could literally walk faster than the planet's rotational speed. Venus also goes in the opposite direction of Earth, so sunsets there are set in the east, sunrises in the west. And last, but not least, Mercury. It doesn't have any moons or rings, and it's the smallest planet in our solar system. A year there lasts only 88 days. So get ready to expand that birthday budget. Mercury is the planet the closest to the sun, but not the hottest. Venus took that title. Mercury is not the hottest because there's no atmosphere to trap the sun's heat there. But it does have wrinkles. Only 1/2 of Mercury's surface faces the sun at any given time, meaning there's an incredible difference in the temperature on either side, and of course these sides switch as the planet rotates. The iron core of this planet has cooled and contracted over millions of years due to the rapid change in heat, which is why wrinkles have appeared on its surface. Well, That's a brief tour of all the planets of our solar system. And one dwarf planet. Sorry, Pluto. Thanks for watching.
It's been more than a year since the James Webb Telescope, which had taken over 20 years to complete, was launched. And for such a relatively short time, the ultra-modern and most powerful in history piece of equipment has already made plenty of discoveries. By observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that appeared in the early universe. For example, look at the closest to us stellar nursery, a region of space where new stars get born. NASA has shared an image from James Webb that shows a small star-forming region. If you look at the picture attentively, you'll see jets bursting from infant stars. Around them, different colored clouds of cosmic dust are colliding with one another. The view is mesmerizing. The red dust consists of molecular hydrogen. You can also notice that some stars have something like shadows. Those hint at the creation of what will later become planets. At first sight, the image may seem chaotic, but astronomers claim that it's a relatively small and quiet stellar nursery in comparison to some others. Many young stars there are similar in size to our Sun, or a bit smaller. The photo itself was taken with the help of Webb's near-infrared camera, NIRCam. It's the observatory's primary camera that snaps images of the cosmos in 2 different infrared ranges. Another amazing discovery the Webb telescope has made is smoke molecules in a distant galaxy. It's the first time such molecules have been discovered so far away from our planet. The galaxy in question lies 12.3 billion light-years away from Earth. It most likely formed about 1.5 billion years after the Big Bang. Despite such a huge distance between the galaxy and our planet, scientists have managed to detect chemical compounds found in soot or smoke, and it's quite a big deal since it has pushed the record for detecting similar complex molecules back by around 1 billion years. This study has also confirmed the sheer power of the coolest piece of space equipment of all time. It managed to make this discovery despite the fact that the spectrometer needed for the measurements didn't perform to the fullest after having experienced a sudden and surprising degradation. The James Webb Telescope has also helped to boost our understanding of exoplanets. Those are planets orbiting stars other than our own Sun. At the beginning of 2023, the observatory spotted its first exoplanet, LHS 475b. It's located 41 light-years away from Earth and is approximately the same size as our planet. According to NASA, nowadays, James Webb is the only operating telescope capable of categorizing the atmosphere of Earth-sized exoplanets. The research team behind the discovery believes such results underline the precision of the telescope. They hope that it will help us locate many more rocky exoplanets that we might be able to colonize in the future. Even though, at first sight, it may seem that the universe is pretty empty, it's actually a very busy place. And Webb has all the necessary instruments to see all kinds of cosmic events happening out there. Just look at this image of WR 124. It's a star on the cusp of its explosive demise. In the image, the star is about to go supernova. It happens when a star runs out of its fuel and explodes at the end of its life cycle, releasing a giant cloud of space dust and hot gas into space. The star captured by the Webb telescope was at the Wolf-Rayet stage of its life. That's a period when a star is shedding its outer layers before going supernova. The next amazing thing discovered by James Webb is a star-planet hybrid with very strange clouds. This bizarre world, VHS 1256b, is actually a brown dwarf. Those are bigger than planets but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us, it appears to be dark orange or magenta. The brown dwarf discovered by the Webb telescope is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars, and to complete one orbit, it needs over 10,000 years. Astronomers first found out about this unusual exoplanet in 2016, But, at that time, they didn't classify it as a brown dwarf, and, thus, couldn't explain its puzzling reddish glow. Now, thanks to the James Webb Telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor. But those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Another recent discovery involves several large galaxies that scientists believe were born not long after the Big Bang. They aren't supposed to be there, and no one expected to find them. But the James Webb Space Telescope has spotted them. These galaxies, as massive as our home Milky Way, are full of mature red stars. Astronomers have analyzed the light coming from them and estimated their age 500 to 700 million years after the Big Bang. It means that they came into being when our universe was very young, almost a baby. But the most bizarre thing about these galaxies is their tremendous size and the age of the stars dwelling there. The data received by the telescope don't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. It also doesn't match the earlier observations made by Hubble. And here, James Webb has captured a distant region of space in unprecedented detail. This section of space is known as Pandora's cluster. In the image, you can see 3 massive clusters of galaxies coming together and forming a megacluster. The combined mass of these clusters acts as a powerful gravitational lens. And thanks to this natural magnification effect, scientists can see other galaxies in the region. Astronomers claim that the most recent image of Pandora's cluster is stronger and deeper than they have ever seen. James Webb has also managed to spot thousands of young stars never seen before in the Tarantula Nebula. This space formation got its nickname because of the appearance of dusty filaments spotted in previous images. It's the biggest star-forming region in the local group, which includes the galaxies nearest to the Milky Way. The Webb telescope's images have helped to shed light on the composition of the Tarantula Nebula. The telescope has also detected protostars, infant stars in the process of gaining mass. Astronomers expect that these protostars will eventually form and shape the nebula further. Among other discoveries made by the James Webb Telescope, you can see the birth of 50 distant stars. Some of them power protoplanetary disks, which might later form solar systems light years away from our own. Here's one more image from James Webb. You can see a supermassive black hole that has a mass of 9 billion suns. It's so ginormous and ancient that scientists are struggling to explain its existence. Astronomers have also discovered a distant ring of dust, rock, and gas that contains a chemical called methylcation. It's known as a molecular building block of life, and it makes most of the organic material on our planet. James Webb helped researchers see powerful sandstorms on a planet 235 trillion miles away. Astronomers were happy to discover this treasure chest of countless tiny sand particles. Now look at this. Do you recognize this image? Those are the so-called pillars of creation. But this new view shows us just how star-speckled that dusty region actually is. You can compare the new photo with the one taken by Hubble in 2014. This is astonishing proof of scientific progress.
Pluto, an exoplanet and now the most famous dwarf planet in our solar system, is hiding somewhere far, far away in its dark corner. The temperature of Pluto's surface is freezing. I mean, wow! At first sight, it's just a distant, icy, and barren celestial body. But could Pluto be hiding something? Maybe even life? Scientists found out that, despite it being so far from the Sun, its interior is still warm. It's been that way ever since Pluto formed. Under the haze-layered atmosphere of Pluto, there's a frigid surface full of craters and impure water ice. There's also a large impact basin flooded by frozen nitrogen. And below that icy crust could be an internal ocean. When the surface of a planet stretches, it mostly leaves many fractures behind. The same goes with Pluto. You can see there are numerous cracks across its water-ice crust. They're of all ages. Some even possibly date from 4.5 billion years ago, from the times when Pluto was still forming. The dwarf planet probably grew because it slowly accumulated small pieces of icy material. It condensed during the time when the outer region of our solar system was forming. This process was going intensely and fast enough to melt the base of the icy layer. The surface of Pluto extended as liquid water at the top of the ocean froze onto the base of its ice crust during its first half-billion years. The ocean may have stopped freezing for the next billion years. The buildup of radioactive heat temporarily balanced the rate of heat escape to space. But as Pluto produced less radioactive heat over time, the roof of its interior ocean continued to freeze, and it probably turned into a 120 miles thick layer between the rock and ice. Crusts were the first hint there might be an ocean there. Scientists got the second potential piece of evidence when they realized the icy shell had managed to glide across an essentially frictionless interior and reorient itself. And it's not just about the ocean here. The cool thing is that wherever there's water, there could be life. A potential ocean under an icy crust is not something that possibly exists only on Pluto. Some icy moons of our solar system have it too, like Saturn's moons Enceladus and Titan, and Jupiter's Europa. Enceladus and Europa could both have salty liquid oceans. Plus, they have similar water plumes erupting from their interior. These geysers tell us these moons have their own source of energy, probably because of radiation or gravity. Either way, that energy is what could support life. Have you heard of Ceres? It's our closest dwarf planet, the biggest object in the asteroid belt between Jupiter and Mars, and the first asteroid we discovered at the beginning of the 19th century. People even called it a planet then. Although it's not so popular, there's a possibility Ceres has a subsurface ocean too. Geysers could be the first sign of that. The water vapor plume could be a result of a meteorite strike that exposed subsurface ice to outer space. Ceres may have its own atmosphere too. This dwarf planet is relatively far from the Sun, but its surface temperature could go up to minus 37 degrees Fahrenheit. At these temperatures, if there was water ice at its surface, it would quickly change to gas, and this could create an atmosphere around this intriguing dwarf planet. Not just oceans, there are many volcanoes across our solar system too. Mercury, Venus, Mars, and Io, one of Jupiter's moons, have them. But apart from the Earth, Io is the only one that has more than 400 active volcanoes. 150 of them erupt at any given time. Scientists suspect there could be some volcanic activity on Venus and Jupiter's moon Europa too. But they can't check if that's true because Venus has an extremely thick atmosphere and Europa has a thick ice shell. And even though volcanoes in other spots are no longer active, we know they used to be because of specific landforms they left behind: hills, valleys, plains, mountains, and especially lava channels. It's like when you're watering your plants on the front porch, you see water flowing down your sloped driveway along specific pathways. This creates small channels, a lot like lava does. Our moon may have also had active volcanoes back in the age when dinosaurs were still roaming around. If they had had telescopes, they might have seen something spectacular: lava fiercely oozing from the surface of the moon. Astronauts took images of Ina, an unusual volcanic deposit on the moon, and there are 70 similar patches in the volcanic plains they found on the side of the moon that faces our planet. Some of them are over 1 billion years old, but some could have been formed less than 100 million years ago, and dinosaurs went extinct 66 million years ago. Speaking of dinosaur extinction, could Jupiter have been the main culprit for that? No one knows where this space rock that hit our home planet 66 million years ago came from, especially with such force. It left a crater off the coast of the Yucatan Peninsula in Mexico, and it probably caused earthquakes, tsunamis, and fierce volcanic eruptions that brought troubles not only to dinosaurs, but to nearly 3/4 of all animal and plant life on Earth. But some believe Jupiter was the one that flung the comet into the Earth. Gravity is a tricky force that can make the solar system act like a big pinball machine. Jupiter is our most massive planet, which means it has extremely strong gravity. It's like a guardian of our solar system that kicks many incoming comets away, sometimes bringing them pretty close to the Sun. As they get there, these comets can experience extremely strong tidal forces that break them apart and, in the end, create long chunks of a comet. And one of these chunks probably went towards the Earth. Have you heard of the story of Triton? Neptune has 13 moons, and Triton is the largest of them. It's the only giant moon in our solar system that has a retrograde orbit. It means it circles its parent planet in the opposite direction of its rotation. Scientists believe that's because Triton used to be in the Kuiper Belt, a disc-shaped area located in the outer solar system, past Neptune's orbit. And it's possible that Neptune's gravitational force pulled it out of that region millions of years ago. Pluto may have originated within the Kuiper Belt too. Pluto and Triton are almost the same. They have similar density, mass, and surface material. Now Triton is locked away in synchronous rotation with its parent planet Neptune, far away from what we believe is its homeland. Now, the most distant object we've discovered so far in our solar system is a mysterious planetoid called, wait for it, Far, Far Out. 1 astronomical unit is the average distance between the Earth and the Sun, around 92 million miles. Well, Far, Far Out is 132 astronomical units from the Sun, 4 times farther away than Pluto. Since it's so far away, Far, Far Out needs about 1,000 years to finish a single circle around the Sun. Far out! Have you ever imagined what would happen if 2 gas giants collided? The chances are small, but if something like this happened, not much matter would be lost, although it depends on the angle and the speed of impact. A head-on collision would make them completely merge and not lose any matter at all, whether we're talking about their gaseous envelopes or their solid cores. But at high speed, their 2 cores would merge and both planets would lose most of their envelope gas. At very, very high speeds, bam, both are gone. If there was an oblique collision, 2 cores could completely avoid each other. Planets would merge, but a substantial fraction of their gases would vanish into space. And in a very oblique collision, kind of like a sideswipe, planets would keep going like nothing happened. There's no evidence for that, but one theory even says Jupiter and Saturn, or at least one of them, might have formed by merging from smaller gas planets. Yep, it's all about gas.
It's dark and incredibly cold. There's no oxygen. There's no water. There's no life. But the James Webb Space Telescope doesn't seem bothered by all this. Its main goal is to find the very first galaxies that formed billions of years ago in the early universe and observe the stars making up distant planetary systems. Its mission is to... But wait, what is that? The James Webb Space Telescope has discovered something absolutely amazing. A star-planet hybrid with very strange clouds. This bizarre world called VHS 1256b is actually a brown dwarf. Those are bigger than planets, but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium, like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us it appears to be dark orange or magenta. The brown dwarf we're talking about is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars. And to complete one orbit, the brown dwarf needs 17,000 years. In fact, astronomers found out about this unusual exoplanet in 2016. But at that time, they didn't classify it as a brown dwarf, and thus couldn't explain its puzzling reddish glow. Now, thanks to the James Webb Telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor, but those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Scientists have been putting forward theories about the existence of such sand clouds on exoplanets for quite some time. But the discovery the James Webb Space Telescope made is the first real proof. The silicate particles on the sandy dwarf are most likely quartz or some other mineral. In size, they're less than a micron, and 1 micron is 1/25th of a thousandth of an inch. In other words, they look like particles in smog. The exoplanet seems to have an atmosphere which contains some water, methane, and other substances and minerals. Interestingly, this atmosphere isn't still. It's constantly undergoing extreme changes. Another cool thing about it, scientists have detected carbon dioxide. And this is only the second confirmed discovery of this gas on a planet outside the solar system. By the way, the James Webb Space Telescope, with the help of which astronomers discovered our sandy brown dwarf, is an absolutely stunning piece of equipment. Around 100 times more powerful than Hubble. Even though the telescope itself is 3 stories high and its size equals that of a tennis court, its mirrors are the lightest large telescope mirrors of all time. When all the 18 mirrors of the telescope were completed during the manufacturing process, their mass was reduced by 92% in comparison to the initial discs. Each mirror weighed a mere 44 pounds. The telescope's mirrors seem to be gold, but in reality, they're made of beryllium, steel gray, lightweight, and brittle metal. There is indeed a gold coating on each mirror, but they can't be produced entirely out of gold since this material tends to expand and contract even with small temperature changes. That's why the total amount of gold in the James Webb Space Telescope is less than 2 ounces. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than -370 degrees Fahrenheit. That's cool enough to make liquid nitrogen. A truly enormous 5-layered sun shield stretches around the telescope and reflects away as much sunlight as possible, letting the telescope stay cool. The telescope was launched near the equator because Earth spins a bit faster there, and this gave the rocket some extra push. The telescope orbits the Sun more than 1 million miles away from Earth, and when it runs out of fuel, it'll keep orbiting the Sun indefinitely. On the other hand, even though the telescope wasn't actually designed to be serviced or upgraded, it might potentially be refueled with the help of robots. This would extend its life. Anyway, if you think that our newly founded brown dwarf is the only bizarre exoplanet out there, let me show you some other breathtaking worlds. There is an exoplanet that is really something else. Just look at its awesome magenta color. You can find it in the Virgo constellation. The planet is called Gliese 504b. It orbits very far from its parent star, 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. One of the oldest exoplanets we know about is about 12.7 billion years old. It's almost 3 times as old as Earth. This also means that the so-called Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its 2 parent stars have had enough time to evolve into a white star and a pulsar, making almost 100 revolutions per second. I bet sunrises on this planet must look awesome. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming the Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's. The exoplanet also produces amazing auroras. That's why when it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf. But later, scientists got some proof that this space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet in the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create mesmerizing light shows. The next exoplanet isn't like any other. It's often called Super Saturn or Saturn on steroids. That's because J1407b has a colossal system of rings. They're 640 times as large as those our Saturn has. This bizarre world is the only planet we know about that has rings similar to Saturn's. If you moved this giant to our solar system and used it to replace Saturn, its rings would look many times larger than a full moon. An exoplanet called WASP-12b munches on the light coming from its star. It's one of the darkest worlds people know about. All because its day side consumes light rather than reflects it back into space. The egg-shaped planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. It might be the main reason for the temperatures on the surface of the planet that can rise up to 4,600 degrees Fahrenheit. The night side of the planet isn't as hot as its day side, a mere 2,200 degrees Fahrenheit. The difference in temperature makes water vapor and clouds gather above the surface of the planet. And from time to time, swirls of material from the planet's superheated atmosphere spills onto its star. What a view! Discovered in 2017, KELT-9b is one of the hottest exoplanets we know of. The temperatures there can reach 7,800 degrees Fahrenheit. For comparison, the temperatures at the surface of the Sun reach 10,000 degrees Fahrenheit. The planet is probably so insanely hot because it orbits extremely close to its star, KELT-9, which is way hotter and bigger than our Sun. Experts believe that the giant star might one day evaporate the entire planet.
This is Neptune. The next stop is Pluto. Stand clear of the closing doors, please.
One day, with top-notch future technologies, one stop from Neptune to Pluto won't seem much further than Times Square from Bryant Park today. There are huge ice mountains on Pluto, valleys that go further than your eyes can see, 160-mile large craters, almost as big as the largest one on Earth, and no life. The reasons are obvious. The long distance between Pluto and the Sun guarantees freezing temperatures on that dwarf planet. It also ensures a trip of a few billion miles. Plus, it's smaller than the Moon, so it would get crowded very soon if people started dwelling there. Still, there's one reason which makes life there not that far-fetched. The Sun has a lifespan and cycles within it. Our solar system used to be nothing but a cloud of gas and dust. As a result of a gravitational collapse at the center of this cloud, the gas and dust started gathering in specific, denser places. These pulled more and more matter as time went on, and something called conservation momentum made the mass start rotating and heating up because of immense pressure. Later, there appeared a disk similar to what Saturn has, but it was made of entirely different substances. And right in the center, there was the ball that eventually became the Sun. A protostar is a young star that's still gathering its mass, and that's exactly what the Sun was before the temperatures and pressures inside of it lighted up its core. Millions of years later, it became the Sun we see every day. But it won't stay this way forever. It will heat up even more and eventually get bigger and denser, turning into a red giant. It may one day get big enough to swallow up Venus and Mercury. Chances are, it might swallow even planet Earth. Even if it doesn't devour our planet, the Sun might get close enough to touch us. Well, if this happened, life on Earth wouldn't be possible. But then, in just a few minutes, the Sun loses about 40% of its mass and shrinks about 10 times what it used to be. It's not as bright, and indeed, not as hot as it used to be. By this moment, Earth will have already been deserted. People might want to start traveling around space, or settle down on another planet where life is sustainable, like the exoplanet Kepler-62f, which, by the way, is even bigger than Earth. While all of this was happening, Pluto was changing. Before, every resource was frozen inside of the dwarf planet. Water, gases like methane, carbon monoxide, you name it. But as the sun was reaching its peak luminosity, Pluto was slowly warming up and losing a lot of what it had to the vastness of space. At the same time, an atmosphere formed up. If the atmosphere gets thick enough, it would create favorable life conditions. Then, instead of spaceships, a tiny percentage of us would be able to set up colonies on the dwarf planet. The temperature is comfortable there, almost t-shirt weather. It even resembles Earth a tiny bit. Canyons filled with water, beautiful endless fields with trees, and lots of space to run around, and mineral water pockets on the ground, good enough to drink. Pluto's rotations are different than Earth's. An Earth day is 24 hours, and sometimes it still feels like it never ends. But on Pluto, a whole rotation around the sun takes 153 hours, because it's pretty far away from the sun. After several hours without sleep, we get tired and our eyes get red. It means we'd have to take several naps throughout the day on Pluto. A year on Pluto equals 248 Earth years. Unless we come up with some sort of technology to get us to live that long, our entire lifespan would be less than half a year on the dwarf planet. So, houses on Pluto might need to be equipped with cryo chambers. Whenever you feel like dreaming for a long time, you jump in it and wake up 50 Pluto days later. On the dwarf planet, there are also seas and beaches. So it's just like a tiny Earth, far away from the actual Earth. The food on Pluto could be tastier. We might find a way to make the ingredients more savory and even try to grow them faster during the trip. You plant a carrot, and 2 days later, it's ready to be in your salad. There could also be new ingredients for our salads on Pluto. Maybe 2-meter-tall mushrooms we've never seen before. The animals we would take with us on the trip would get released into their new home forever. And with time, they would evolve and adapt to their new environments. The law of the jungle could change a bit too. Lions might not be kings anymore. Deer are. Their antlers are twice the size of what they used to be. But to be fair, so are the deer. Most of the animals that were already here used to live underwater. But with time, the amphibians started shifting to the surface, just like Earth at the beginning of life. Pluto could only be a temporary home though. Once the sun has finally reached its final phase, Pluto would get frozen and lifeless again. People instead would need to try to find a planet that stays in the Goldilocks zone of another galaxy. The Goldilocks zone is the exact proper distance from the star like the sun, where the temperature is perfect for the water to stay liquid. It's the rule scientists search for when looking for other planets that can sustain life. We can try setting new colonies on one such planet, or even try to set up our own artificial home. Not exactly a planet or a spaceship, but a combination of both. Something huge built right in space, say a wheel with gravity everywhere we go, so we don't fall off. It would float in space toward the new exoplanet, capable of fitting entire states in. This whole trip might happen just because the sun first grew too much, and then, having reached the culmination of its life cycle, it would finally become a white dwarf. It's going to be a pretty long journey, and entire generations will be born here. You'll have a choice. Sleep your way through the journey until humans finally reach their new exoplanet, or enjoy the trip in this fantastic spaceship. There's all you need on board. Malls bigger than those on Earth, large futuristic cities, even places to farm, fields with rich soil made artificially, and finally, after a long journey, the exoplanet. It's even somewhat better than Earth. The planet is giant and has more continents. The continent's center isn't as far from oceans, which means there aren't as many desert areas. Though the sun of this planet is an orange dwarf, it's not as hot as our yellow dwarf sun today. It's a bit smaller, but here's the kick. Orange dwarfs live somewhat longer. They remain stable for between 15 billion and 45 billion years. Despite that, this new planet is full of rainforests because the planet itself is warmer. It means more biodiversity and creatures we've never seen before. But even if nothing out there is suitable, we could try and terraform this planet instead. If we take Mars as an example, We could create a greenhouse effect by smashing ice-rich comets and releasing ammonia in them, making the planet warmer. We could also start planting trees. We'd probably need some Earth soil to do that, or we'd have to modify Mars's soil to be similar to ours. Sooner rather than later, the atmosphere would be close to the one we have on Earth. We'd be able to breathe too, because of the trees. Then, we can melt Mars's polar ice caps and voila, water. The problem is the solar winds and sun explosions that might strip it of an atmosphere just as quickly as we can create one, if not faster. It has no magnetosphere either, which means it can't protect us from radiation, so long-term Mars wouldn't be a good choice. Maybe out there, in the vastness that is space, there is a perfect planet waiting for us. Wow, the James Webb Telescope has been fully deployed! If you're interested in astronomy or space, you've got to be excited about the James Webb Space Telescope. Here's why. For starters, it's huge. How huge? The primary mirror of the JWST is over 21 feet wide. The Hubble Space Telescope, the previous largest eye in space, has a mirror of about 7 feet, 10.5 inches. By comparison, if you place the two telescopes side by side, it'd be like putting a horse next to an elephant, and elephants are enormous. There's a perfect reason why the Webb, as it's affectionately called, is massive. It has to be huge because it's not an optical telescope in the traditional sense that most telescopes are. The JWST is an infrared telescope. It sees heat. Infrared light has a longer wavelength than visible light, so it needs a larger mirror to focus that light. So what do we have here with the James Webb Space Telescope? We have two never-before things going on. We have incredible technology and incredible science missions. Both the missions and the technology are out of this world cutting edge. The Webb is a classic example of engineering in the service of science. Because of its greater light gathering power, the James Webb Space Telescope will be able to take images of things that we were never able to see before, but have always wanted to see. Things like exoplanets and the first galaxies in the universe, and stars and planets forming inside nebulae. And you can bet that there'll be plenty of surprises too. The James Webb Space Telescope has several technological tricks up its sleeve, which promise to provide its greatest scientific discoveries. The Webb has a coronagraph, and a very special coronagraph at that. The coronagraph is the tool that will allow the first real pictures of exoplanets. The coronagraph blocks out the bright pinpoint light of stars, which we already know have planets orbiting around them. Without the coronagraph, the starlight would make things too bright to see these planets, because planets are hundreds of thousands of times dimmer than the star. But with the coronagraph blocking the starlight, the exoplanets come into view. And the JWST coronagraph can block the light from up to 100 stars at once. We can expect a swarm of exoplanets. This brings us to the next high-tech gadget the JWST has up its sleeve, a no-slit spectrograph. Usually, an ordinary spectrograph will have a slit to allow a sliver of light to enter and be diffracted. Diffraction is the scattering of light to reveal the spectrum of the light's component wavelengths. But the James Webb Space Telescope's work is so sensitive that a sliver of light would overwhelm the optics. So a no-slit spectrograph was installed. The starlight gathered from the big mirror is sent into a fiber optic cable to send only a single spot of light into the spectroscope. And that's where the grism takes over. Sir Isaac Newton used a prism to discover the spectrum of sunlight, Roy G. Biv, as you may recall. But the Webb uses a grism. That's a compound word, like smog, which is smoke and fog. A grism is a graded prism. That means it has itsy-bitsy, teeny-tiny grooves that diffract the spot of light the big mirror sends down the fiber optic cable and into the spectrograph. The science of reading a spectrum of light is called spectroscopy. By analyzing the spectra of light from the exoplanets, the JWST will determine what gases are in the planet's atmospheres, as well as their density and even their temperature. It's an incredible advance in our knowledge. We'll be able to tell if a planet has oxygen or nitrogen, or methane, and other gases that may or may not indicate that the planet is habitable. Another Earth, perhaps. Presently, the JWST is parked in its permanent location. Unlike the Hubble Space Telescope, which orbits the Earth, the James Webb Space Telescope orbits the Sun. It orbits the Sun at one of the gravitational balance points between the Earth-Sun system. It just stays there without having to use much or any fuel to hold its position. So, as the Earth orbits the Sun, the James Webb remains parked at a spot that is also orbiting the Sun. There are 5 gravitational balance points between the Earth and Sun. They are called Lagrange points, after their discoverer, Joseph Louis Lagrange, in the 18th century. The Webb is parked at L2, the second of the 5 Lagrange points, which lies 932,000 miles out into space, way beyond the Moon. All this to observe a spot of infrared light. But first, the engineers must get, or acquire, that spot of light. To get a spot of infrared light, the 18 hexagonal mirrors had to be unfolded from their position inside the Ariane rocket that sent the Webb into space. Once the mirrors have unfolded, their positions must be adjusted to microscopic level accuracy so that all 18 mirrors produce a single image. Several tiny motors are attached to each mirror segment to make these adjustments. These motors, which must be activated individually, will gradually pull the honeycomb-like mirror segments into alignment. It's a critical part of the mission and takes months to complete. To align the mirrors to produce a single spot of light, the James Webb Space Telescope can't be jiggling around. The telescope must be kept absolutely motionless, and that requires 2 other cutting-edge technologies, the sun shield and the cryocooler. In space, direct sunlight is very hot, and shadow is very cold. Therefore, the James Webb Space Telescope brought along its own high-tech sun shield. It's huge, too, as big as a tennis court huge, comprised of 5 individual layers of Kapton film, only a millimeter thick. Each layer of the sun shield has to be remotely deployed individually using a system of 8 motors and 139 actuators with thousands of parts. The purpose of the sun shield is to help the JWST stay cold. The colder the better. And colder is what the cryocooler is for. Temperature can be measured 3 different ways: in degrees Fahrenheit, where water freezes at 32 degrees and boils at 212; in degrees Celsius, where water freezes at 0 degrees and boils at 100 degrees. But neither of these thermometers have a starting point. So, Lord Kelvin, in the 19th century, devised a 3rd temperature scale, the Kelvin scale, which starts at absolute 0, the coldest temperature possible. The onboard cryocooler will cool the JWST to just 7 degrees Kelvin, 7 degrees above absolute 0. At this temperature, virtually all heat from motors is removed, and the telescope will be able to focus the light to a point without any noise, basically any motion interfering with the quality of the image. Finally, after all this incredible technology functions remotely as planned, we are almost ready to observe the infrared images from the giant multi-segmented mirror of the James Webb Space Telescope. Almost ready. A telescope can collect all the light it wants, but in the end, it must also be able to detect what it's collected. If the light is not detected, it's not truly observed. Enter the piece de résistance, the infrared detectors. The Webb has 15 of them. The specially fabricated semiconductor material produces a slight electrical charge when struck by a photon of infrared light. The Webb's infrared detectors can produce a 1,000,000-pixel high-def image. A few of the detectors can produce a 4,000,000-pixel image. They must be durable enough to last 10 to 20 years without warping or corrupting, all while working at 7 degrees above absolute 0. In themselves, the infrared detectors on the JWST are an engineering marvel. But what are they going to take pictures of? The missions of the JWST. Well, they're cutting edge too. 70 of the first 280 target observations are exoplanets. Is there another Earth? Which exoplanets seem habitable? The Webb telescope will provide detailed spectroscopic analysis of the atmospheres of thousands of known exoplanets. For the first time, we will see images of exoplanets as they appear in infrared light. Cosmology, the study of the universe, is perhaps the primary mission for the Webb. Galaxies receding away so fast that their light is stretched into the infrared will be a prime target for observation. Hundreds of hours of observations are necessary to collect the faint infrared light from these first galaxies formed after the Big Bang. The JWST will give us a picture of what the infant universe looked like. Astronomers will learn new information about the dark energy that is driving the expansion of the universe and what role, if any, black holes play in the formation of galaxies. Star formation in the Milky Way and nearby galaxies is also part of the mission of the James Webb. By imaging hundreds of solar systems forming around newborn stars, astronomers will establish a definite history of solar system development. Now fact will replace theory, and a big step forward will be taken in our understanding of space. The James Webb Space Telescope is a bold endeavor that will mark an epoch time in scientific history.
Frozen plains, mountains with white peaks glistening in the distant sun, and rustic red snow. Welcome to Pluto, where nothing makes sense anymore. Looking at it from a distance, the ice ball planet is mostly predictably winter shades of white and light blue. Once you land on the surface, you'll notice familiar blue skies as well. But see that whale-shaped red stain running along the equator? Right there to the left of the white heart-shaped region, there she blows. This spot is bigger than Alaska, and it's a mystery to scientists. That's not red clay soil or anything you'll see on Earth. That's Pluto's version of ice. Scientists believe it's red because the atmosphere drops this strange soot-like chemical called tholin on the surface. It's the same stuff that explains the red cap on Pluto's moon, Charon. Now, let's zoom in closer on the whale. Oh look, we have a mountain range. Yes, Pluto's red ice is like rock, hard enough to form entire mountains. Those white peaks standing out against the dark red aren't snowy caps like we have on Earth. That's frozen methane. For such a small planet, Pluto's mountains are epic, bigger than Everest and made entirely of ice. Such a bizarre landscape can't be found anywhere else in our solar system. Yeah, Pluto's a pretty harsh cold place. Temperatures there can dip to minus 400 degrees Fahrenheit. The coldest ever recorded on Earth was in Antarctica, a measly minus 135. Now let's head back to the heart of Pluto. That's actually a vast plain covered in nitrogen ice. Scientists discovered that Pluto's heart makes the winds on the planet blow. Craters are also big, and some of them show signs of filling and erosion. That's something that happens right here on Earth. When land is worn away and shaped by natural forces like wind, water, and ice, that's erosion. So, what makes all this so special on Pluto? It could be evidence of tectonic plate activity. You know, big plates of land surfing on liquid rock, forming mountain chains, breaking continents apart, putting them back together. That's something scientists so far have only ever seen on Earth, not on any other planet in the solar system. Now, looks like Pluto could be more like our own planet. That, and there's water on Pluto, 1/3 of its surface in fact. But of course, it's not like Earth water. It's more like a rocky slushy. Yum. Still, no signs of life out there, at least not for now. It's taken a long time to get the little information we know about Pluto. It was first discovered almost 100 years ago and deemed the 9th planet from the Sun, until 2006 when its official planet membership card was revoked. Poor Pluto. It was dubbed the biggest dwarf planet in the Kuiper Belt, a region outside our solar system full of other dwarf planets and icy bodies circling the Sun. A few months before that, they launched the New Horizons mission. It was the first space probe researchers sent to Pluto in 2006. Zipping at over 35,000 miles per hour, that's 45 times the speed of sound, it still took the probe almost a decade to reach its destination. That's how far away the tiny planet is. In fact, Pluto is nearly 40 times the distance from Earth to the Sun. If you were there looking up at the sky, you'd see the Sun as a tiny dot like any other star in the sky. Once New Horizons finally reached Pluto in 2015, it got close enough to get some incredible pictures of the surface. It also collected important data and observations, like those strange red spots and that heart-shaped region. But Pluto gets even stranger, especially its orbit. Most other planets go around the Sun in almost perfect circles with the Sun close to the center. The Sun is nowhere near the center of Pluto's orbit, and the orbit is so stretched out that Pluto sometimes crosses into Neptune's path and gets closer to the Sun than the blue gas giant. So, the unusual effect of the strange orbit? Pluto sometimes has an atmosphere, and sometimes not. When it's closer to the Sun, a thin atmosphere of nitrogen forms. But once the planet starts moving further away from our Sun, the atmosphere freezes and falls to the surface in an ice storm of epic proportions. Pluto is probably a lot smaller than you imagine. If you put it on a map of the Earth, it would only span about halfway across the US. Yet this little planet has 5 moons spinning around it. And life on Pluto would be one endless year for us humans. Imagine no birthdays your whole life. Since it was discovered in 1930, we still haven't seen it complete a full circle around the Sun. 1 year on Pluto is 248 Earth years, and we'll finally see that happen on March 23, 2178. Mark your calendar. Since Pluto got kicked out of the official planet club, Neptune became the last one in line. It's actually a big ball of ice and gas. So, like with the other gas giants, if you tried to land on this planet, you'd just keep going deeper and deeper into seemingly endless clouds and atmosphere. Funny thing about the blue planet, it might not have a rocky surface like you and I are used to, but its surface-level gravity is about the same as Earth's. Same can't be said for any other planet in the solar system. As we make our way closer to the Sun, we pass the next gas giant, Uranus, that non-conformist planet that goes around the Sun basically rolling on its side. One full orbit is 84 Earth years, so you might be lucky enough to celebrate your first birthday in your whole life there. Only one party, so you better make it count. And now we approach the jewel of the solar system, Saturn, the second biggest planet after Jupiter and another gas giant where you'd sink in an endless atmosphere if you tried to land a spaceship there. Saturn is the least dense planet of them all, meaning if you put it in a giant glass of water, it'd float. Those famous rings are made up of dust, ice, and rock. Some as tiny as a grain of sand, others bigger than houses. But get this, Saturn's rings are raining down on the planet, enough to fill an Olympic-sized pool in a half an hour. At that rate, the famous blue ring system will disappear completely in 300 million years. By the way, Neptune, Uranus, and Jupiter also have rings. They're just not as visible and bright as Saturn's. Imagine combining all the planets into one. Now make it 2 times bigger. Still not as large as Jupiter. Scientists called it a failed star, since it's mostly made of helium and hydrogen, just like our Sun. But jumbo-sized Jupiter still isn't massive enough to kickstart the chemical processes that could turn it into a star. It's the fastest spinning planet, so it takes only 10 hours to complete a full rotation on its axis. Imagine trying to squeeze sleep, work, friends, hobbies, movies, shopping, your whole routine in less than half an Earth day. Magnificent tall mountains, the highest in the entire solar system. The most epic dust storms ever. Deep valleys, craters. I'm talking Mars, our potential home in the future. If you love sunsets, you'd definitely enjoy Martian ones. They're incredibly blue, while the sky throughout the day is pinkish red. Even though Mars is our closest neighbor, from the surface, the Sun would look half the size it does from Earth. So, not as close as it seems. Oh, and if you always dreamed of becoming a basketball player, Mars is your place. The red planet's gravity is only 37% of Earth's, so you jump 3 times higher there. Venus is a planet of extremes. The hottest surface, the most volcanoes, the brightest planet, and the closest one to Earth. It's also the slowest spinning and barely rotates, making a day on Venus last 243 Earth days. You could literally walk faster before the planet makes a complete turn. Venus also rotates in the opposite direction that Earth does, so sunrises are in the west and the sun sets in the east. Mercury. It doesn't have any moons or rings, and we're talking about the smallest planet in the whole solar system. A year lasts only 88 days, so if you live there, you'd have a lot of birthdays. Mercury is the closest planet to the Sun, but it's actually not the hottest. That prize goes to Venus. Temperatures on Mercury don't get as high as on Venus because it doesn't have an atmosphere to trap heat from the Sun. What Mercury does have is wrinkles. Its iron core cooled and shrank, causing the surface to contract too, and leaving all those wrinkles. That, or because it's so close to the Sun with no SPF. Maybe.